Going into synthetic kicks, which is the reason we're here today. We have with us today Kedar Benjamin, and Kedar is a designer whose work exists in the convergence of computational design and additive manufacturing. His personal work centers around the concept that the future of objects can be made locally, sustainably, on demand, and customized to the needs of a user or user group. So he's the founder of Benjometry, and he's an independent designer, and we're super excited to have him today. So
thank you so much, Katrina. I just want to give another recommendation that you guys should definitely attend CD Next, because Luis Bougen, who works at Zellerfeld, is going to be speaking there. And he's the person whose entire system that the submission system for Zellerfeld is made by him. So we're going to be using his system today.
That's very exciting.
Yeah.
I just want to also add about, because I know that we get a lot of questions about the webinar being recorded. It is recorded and it's going to be sent to you a couple of days after we complete it. So just keep this in mind. And Kedar, sorry, like I just want to make sure, do you have like your chat switched to everyone?
Yes, I do.
Perfect. Okay, so then I'll leave it to you from then on. Thank you.
Okay, cool. I'm gonna stream my whole screen. One sec. Yeah. Okay, perfect. So I guess what I should start with is that everyone should join the Zellerfeld Discord, and first take a look at what the guidelines are. So the design guide channel over here, I'm just going to share the link one more time. This is the Zellerfeld Discord, and make sure you read this properly and go through all of the instructions. Obviously, while I'm teaching you how to model, I'll make sure that we follow these instructions, but it's important that we look at them. So this also is one more link that I was just share to everyone. Yeah. So this is the link for all of the files that we will be using. And we're going to start off in Blender, making the base shape of the shoe. And later, wait, here. Yeah, we're going to start in Blender, making the base shape of the shoe. And we'll follow these guidelines like the sole height and thicknesses and all of the other guidelines that Zellerfeld has put forward. And at the end, we will, or towards the later part of the webinar, we'll go into Houdini and use MLOPs to texture the shoe and create closed wall and open areas that can be printed with different infill characteristics, which will give an appearance of different textures. All right, so I'm just going to start right now. So the first thing you want to do is go to the Discord and look for the last. I think it will be in tools and resources. Yeah. Now we're going to use the more traditional last low poly, and that's because it just has a better toe box. So I've downloaded it over here. And everyone, please download this last from the Zellerfeld Discord over here. It's in the tools and resources, and post it over here. And it's also inside the files. So if you download the file that the Google Drive file that I put, you can also find it over there. Anyway, I'm going to open up Blender. And you can use pretty much any version of Blender you want. Blender, I'm using Blender 3.6, but it doesn't matter. A to select everything, X to delete, and then you have to click to confirm. So I've deleted all of the objects in the scene. I'm going to go to File, import obj, my downloads should be here. Okay. And you'll have to zoom out quite a bit because the last is quite large. Blender's units are, so you zoom out with the scroll wheel, and Blender's units are in meters, but the last is in millimeters. So you have to zoom out quite a bit. And I'm going to go here to the modifiers and add the subdivision surface modifier. So this is just going to smoothen it out a bit, and it adds more faces. And I think most of us know what this is, but it's the same as like sub D in Rhino and in Gravity Sketch as well. And what else I'm going to do is click on this little triangle on cage button. So when I click on it, I select it and I go to edit mode. You'll see that it's on the cage, and that's what we want. If this wasn't on, it would be more like this. We would see the low poly version, but we want it on cage. And okay, I'm going to duplicate this. So Shift D to duplicate, and then it follows your cursor. So you just have to right click and it will go back to its original position. So now that we've duplicated the last, we can use this one. So I've turned off the visibility for the original. Over here, there's a little eye icon. You can turn off the visibility using that. And we're going to use this to build a shoe. Now, this shoe that we're making is going to be a little bit basic, but when you submit your own shoe, it would be cooler if you could do something that is not this basic. But for the purposes of the webinar, we're just going to do it in a more simple way because we can get through all of the content that we have to cover a little bit faster, and hopefully cover a little bit more extra stuff, which like rendering, which if we have time, we will cover that. So I've selected using the left click. I'm dragging boxes and holding Shift to select multiple points. And then I hit X to delete, and I click on vertices. So I don't want the vertices. Looks good. These parts need to be moved down. So what you can do is select both of those vertices and click G and then G again, and just move them down a little bit. These two, G and then G. And then what that does is it slides it along the edge. So you can slide it this way, but we want to slide it downwards. And yeah, that looks about right. I think something unique about the way that Sellafield or other FDM 3D printed shoes are made is that you need a really large collar region. And you also need to make sure that the ankle is uncovered. And right now they don't have any perfect guidelines for that. But what you can do is download this zip. So you go to the Sellafield Discord, see the FRT NAMI reference zip. I already have that downloaded, but I'm going to download it again. It says potentially dangerous download, which it is not. 1 second, I'm going to stop my video. Okay, perfect. So in the zip, just going to unzip it. Nice. In this, yeah, you'll see FRT NAMI reference shoe. That's the file that we want. So I'll go back into Blender. I'm not in edit mode. Tab is how you exit and enter edit mode, by the way. Import STL and downloads FRT NAMI reference, FRT NAMI reference shoe. That's the one that you import. And it might take a while to bring in. But what you want to do is align this with the last. And this is a good reference to see where your collar is. And I actually think the previous collar was fine. My bad. But it's fine. I mean, it's not really a bad thing that it's lower. It's just a different kind of shoe, I guess. So if you really line it up, you can use it as a reference. But you generally want to follow this collar line because SideFX has experimented with their method, and they found that this collar line is pretty much the best. Like my own shoe with SideFX almost perfectly follows this line, except I have a bit knocked off at the back and the front is a little bit taller. But generally, you want to kind of follow this template. So let me just undo all of that because it was unnecessary. Okay, perfect. Let's just see. Let me just make sure it was. Yeah, I think it looks to be fine. And this actually might be the collar line of the Heron Preston shoe as well. So something that we will do right after this is make a template for the collar in Rhino. And if you don't have Rhino, don't worry about it because it isn't that important. But it just makes the shoe a little bit more precise, I guess. So every time we do a step, I'm just going to duplicate it and move to a new mesh so that we have the previous one here and hidden. And we can go back a step. Let me save this. Cool. Now I've hit A to select all the vertices. And I go to face, extrude faces along normals. And that's going to do what it says, extrude the faces along normals. And once you left click, so I left clicked and it accepted basically. Here you want to make it something like 6 mm or 5 mm. I'm going to make it 5.5 mm. Maybe that's a bit too much. Let me make it 5.25 m, which is actually mm. So like I said, the meters, millimeters, the last is in millimeters, blenders, units are meters. Okay, that looks good. By the way, I'm moving around with the shift and middle mouse button. So that's the scroll wheel, pressing down the scroll wheel and holding shift to pan. And then you can just drag the mouse without holding shift with the scroll wheel pressed. So middle mouse button pressed to orbit. And this looks good to me. I'm gonna undo. And I'm gonna do Shift D, which is duplicate, but it's still part of the same object. So we wanna press P to separate and then separate by selection. Okay, perfect. And we will work on this mesh. So I hit tab to exit edit mode and then hit tab again to enter edit mode on this mesh. And I have this X-ray turned on. Sorry, I forgot to mention. You can press X. Oh, No, you can click on this to toggle on and off X-ray. It's Shift X, is it? Nope. Anyway, I'm sure there's some shortcut for it, but I've forgotten it. So what I'm going to do now is make the sole. Oh, right, important. Before we make the sole, let's get our templates out. So we need a template for, like the document says, it needs to be between 12 and 35 mm. So we can bring out a cube and let's give it a size of 12. Then we can move this G to move, which is the grab key. Grab is G. X, so it moves in the X direction, and we move it underneath the sole. And it obviously isn't directly underneath it, so we can go G, Y, move it directly underneath that. And then maybe move it down a little bit, so G, Z. Yeah, looks about good. We do the same thing, make another cube. So Shift A and mesh cube. And let's make this one 32. Is it 32? Or 35? My bad. G, X, G, C. Now when we turn on X-ray mode, well, there are two ways to have X-ray mode. There's this way, which is like fully X-ray, and then this way is like transparent. So you can see here, viewport. Yeah, this is like the fully X-ray where you see the wireframe, and this is like transparent. Coasted, I guess, is the same. Yeah, that's how it is in Rhino. Just gonna move this up a tiny bit. Cool. So now we know from the, so in the guidelines it says we consider the distance between the higher point in the bottom surface of the last mesh to the lowest point in the shoe mesh. So the lowest point of the shoe mesh cannot exceed this. Anyway, let's start modeling. So I'm just going to select, oh no, all of this. So I've selected all of the bottom faces and I'm going to hit E, which is going to extrude it. And the direction that it extrudes initially is going to be, oh, my bad, I didn't select all of them. You can hit Control Z to undo. Yeah, there we are. Just making sure. Cool. E, the direction that it chooses to extrude them is not exactly downwards. It's the average of all of the normals of each face. So the line pointing outward perpendicular from each face or each vertex, those averages is the direction that it extrudes, but we don't want that. So we go Z, and then it starts extruding in the Z direction. I had to hit Z twice. And let's not make it a very high volume shoe. I don't think that's really necessary. So when designing for 3D printing, one of the things that you have to worry about is the volume. And the higher the volume, the more expensive it's going to be, and the more time it's going to take, and the more material it's going to use. So you don't really want that usually. I'm going to hit S, Z, so that's scale on the Z axis, and then 0. And that's completely flattened it. Okay. It looks interesting. I'm going to keep the last, oh no, not one. I'm going to keep the last as a reference to make sure that we don't accidentally intersect it. And last, if you aren't familiar, is the inside shape of a shoe. So it's the shape that your foot would fit into. So with this series of points, which I've drag selected, box selected, I think I'm going to scale this on the y-axis. So S, Y. And these ones as well. S, Y. And I think those rear ones can go out a bit. And I do warn against making it like super pointy, because when we texture it, we're going to be texturing it using the bottom view. So it might not, the texture might stretch a bit and might not look too nice. But I'm going to bring it up a little bit, like your maybe, and also bring these back. Yeah, cool. Then these G, Z, bring it up. I'm going to rotate it a little bit. Yeah, it looks like the back is a little bit too wide. So S, Y, again, reduce. Oh, okay. I'm just going to review a little bit. So for the extrude step, let me just go back. This. You can hit A, face, extrude faces along normals. And over here, you want to type 5.25. And I'm just going to undo so that I have all of the outer faces selected. Shift D to duplicate. And then P, separate by selection. There we are. So now you have this outside mesh, which you can use. And then to get all of those faces, okay, select all of these and then extrude with the E key. So E and then Z and then Z again, so that it goes straight downwards. If you want to import the last, that's going here, file, import, obj, and then you go to the more traditional last here. Anyway, get back to where we were. Yeah, here we are. So now that we've kind of got a base shape for the shoe, I think something that we can add is some embellishments in the sole. Oh, that is weird. Oh, I actually didn't bring these up. She didn't bring these up to the correct position. Yeah, okay. I mean, we're still within the tolerance. This is the upper tolerance. This is the lower tolerance. I think we can still bring all of these points down a little bit. Yeah, I'll just continue, and like if there's anything that you really missed out, please watch the recording and DM me on Instagram or something if you can't figure something out. And by the way, for those of you who weren't able to install MLOps because you had some error or something, I also had quite a few errors. So go to the MLOps Discord, which I will actually link right now. And ask people, because I'm not the developer of MLOps, and I had quite a few issues actually preparing the webinar because a lot of things wouldn't work and there were errors upon errors upon errors. So it's quite a finicky software that we will be using. Let me just type that. Zoom to fit hotkey. I'm not sure. I mean, you could probably Google that. I haven't had to use it, but I know I have had to use it in Houdini, but I haven't had to use it in Blender. I'm pretty sure I'm like, I would say 90% sure there's one. Okay, onto the sole, which I think we have to make something interesting here for the AI to give us a result which is interesting. I think what we could do is select a bunch of faces and extrude them downwards, and then maybe merge some polygons or something like that. Actually, yeah. Oh, okay, that would not look too nice. We use these as well. So I hit the I key. Wait, let me just select all of those. Selected all of these, and I hit the I key. And now I'm moving my mouse inside, and it's kind of shrunk all of the faces. So that's inset. And here, maybe we can move the points around a little bit. I think this is a good point for me to just turn off the subdivision view so that we can see what it looks like low poly. And sometimes you want to adjust these things in low poly because when you make something look a little bit more smooth a little bit less jagged in the low poly, it ends up looking much more smooth in the subdivided state. So I guess that's what I'm doing right now. So I'm using double tapping G to move these along the edges. I think I'll move these down. GZ to move them down. Okay, that looks good. Until now, I don't think we've really had to worry about overhangs, but that's the next thing we're going to check. I think we could merge some faces over here, like this edge. So I've selected both of these vertices and I hit X, and I don't click delete vertices. I go down to dissolve edges. And that actually does look a little bit smoother. And sometimes when you make like these pentagons, even though usually you're supposed to use only quads, sometimes when you use n-gons, as they're called, because they have n number of sides. So the person who made the last sweat, he modeled this with an n-gon, and it's a lot nicer than what it would be if he had done like an extra line over here. Sometimes they look nicer. So you can use them. You don't always have to use quads all the time. Yeah, I think that looks more interesting because the flow of the surface is nicer. When you want to check out how the surface flows, increase the subdivision level, exit edit mode, right click, and then shade smooth. You can get the last of the foot base in the ZLFL Discord. So if you scroll up, or I can just send the link again. Yeah. You'll have to look for it in the tools and resources channel. Anyway, I think this looks good, although it's not how I did the one in the file that I shared with you in the Google Drive. And I kind of forgot how I did that one, but it's not that important, so it doesn't matter. I'm also going to make a bit of shape on the top. So what I'm going to do is hit C, which will give me the circle, and I can change the size of the circle with my scroll wheel. I'm just going to drag and select all of these points. Except for maybe those ones. Cool. And I'm going to go again to face, extrude faces along normals. And let me just make those 1 mm. I don't want much of an offset. Let's see how it looks with the... Yeah, that's a nice crease just running along the whole thing. Looks nice. I guess this part is kind of not that nice, but it doesn't matter. What you could do is go along the whole thing and just delete. Yeah, I'm going to do that actually. So I'm holding Control, click on one point and then hold Control. And then you can select like whole lines of points in between the one that you clicked on previously and the next one that you click on. X, dissolve edges. Yeah, looks cool. All right, now it's time to join it with the inside. And in the files, in the webinar files, you'll also see a low poly version of this that you can save, and you can use that one instead if you like that one better. You see, maybe this would look nicer. Nope. Okay, I'm gonna hide this. And this was the inner piece that we had earlier. And it's directly stuck to the last, so it's like perfect to the last. I'm gonna hide this. Yeah, you can see that it's like stuck to the last. So I will select both these, Shift D to duplicate, then turn off the visibility for everything else, and Control J to join. Then I hit Tab and I'll turn off the ghosted mode and select like 4 points over here and hit F, and that makes a face. And don't worry about this pinching, you'll fix it later. You can hold Shift to select two vertices on the side of this face that you just created, and then just hit F, 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 and just keep pressing that key until it closes in on itself. And then you hit A, Mesh, Normals, Recalculate Outside, and that'll fix all of those weird issues. Now, if you don't have Rhino, don't worry about this step. It's not a big deal. Let me just shade this whole thing smooth. Yeah, it's not a big deal. But if you do have Rhino, yay, you can just make your shoe a little bit more accurate. Cool. I'm going to export this. So for the purposes of exporting it, I will export it as an OBJ. So go to File, Export, OBJ, limit to selected only, and don't apply modifiers. So you have to uncheck the apply modifiers and make sure that it's selected only, and export. That's great. Now open up Rhino. Okay, go to new and go to small objects millimeters. And that's the template that you generally want to use for this. Cool. And now I can just drag and drop it. So there's no like going here and importing it. You can just drag and drop it. Import file. Okay. Oh, there it is. So in Rhino, the scroll wheel is to scroll in and out. Shift and right click is to pan, and then you hold down right click to orbit. And right now it's in wireframe mode. So you want to go to shaded. And here we can see the shoe, the low poly of the shoe. And then we can do 2 sub D. And I will click on delete input, yes. Nice. We're going to do the same thing with the last. So just find the last. It's in my downloads. That's weird. Where'd it go? Okay, anyway, I have all these specific benefits. I mean, you can make it in Rhino. Oh, right. I'm so sorry. You can make it in Rhino, but the benefit of using Blender is actually something I'll just show you right now. Let me just R minus 120. Oh, sorry. R 120. So that's rotating at 120 degrees. And then you go to preferences and look for add-ons. And then you search 3D print mesh toolbox. I already have it, but you can just, it will be like, it won't be enabled for you, but you have to click this checkbox and enable it. And then once you enable it, this thing on the right, you can hit N, or you can click on this thing. Just hit N. Oh, no, hit M, sorry. N, and look for 3D print. And then you can click on overhang. And, oh, right, you have to, my bad. I've just duplicated it. And then I will apply all the modifiers and then do the same thing. Apply. Then I check for overhang. Hit tab and then go to face mode and click on this. And here we can see all the overhang faces. So according to Zellerfeld's guidelines, let me just pull those up right now. Design guide. Yeah, here we are. So you can only have overhangs in these green areas, and you don't want to have overhangs in any of these areas. And they have become very, very strict about this. So the end of this webinar might just be 1 hour of me adjusting the mesh so that it fits. But it's the most important part, and it's the only way that the bot will accept your thing, because the bot checks it using the normals of faces, and it checks. And if you don't do it right, you just have to fix the mesh and then send it again. But this is the most important thing. You rotate it by 120 degrees and make sure that there are no overhangs in this red area. And this area, it's okay to have overhangs because that's where the support material comes when the shoe is printed. And this is the position in which the shoe is printed. So that's why it's good to do it in Blender, or it's good to have Blender around so that you can check this while you're modeling. And there's another way to check this actually. So this is not this, wait 1 second. Yeah, this is not subdivided. So I can go to, my bad, go to vertex mode and turn this off. I'll hit N again. Look for mesh analysis and overhang. Oh, yeah, this happens sometimes with this. You have to add a triangulate modifier. And once you add the triangulate modifier, it kind of figures out what the actual normals of the mesh will be, because it isn't triangulated while you're doing all of this stuff. But if you have the triangulated modifier, it knows which direction each subdivided face is pointing. So while you're in this mode, you have like a live visualization of the overhang. So you can actually model and you can get pretty wacky and make sure that you aren't violating the manufacturing requirements. Oh, sorry. So if I can move this way and see, okay, there's a tiny bit of overhang over there. And just move this back. And yeah, you can really have fun with it. I'm gonna undo all of that. Actually did look kind of cool. Nah. Okay, but basically you can mess around with the mesh and see how it looks, see how the overhangs turn out while you're modeling using Blender, which you can't do using sub-D in Rhino, but you could maybe build a grasshopper algorithm that does that for you. All right, cool. Let me just get back into Rhino. Oh, just made the chat full screen. Here we are. Where were we? Yeah, importing the last. Okay, so I'm going to go to a different layer and import the last on that layer. Have all my lasts. Okay, here's the last, and this is also like a low poly mesh, so you have to do 2 sub-D once again, and delete input. Yes. And just look inside, making sure it's all okay. Cool. So if you notice in the Google Drive that I shared, the Google Drive link that I shared, there's a file with there's a file with a gh.gh file. And what I'm going to do is just show you how that file works. Okay, so this is like my usual last template cutting file. So the first thing I have this open, you see this is the same file, synthetics cakes December 10th.gh. Thank you so much for putting that link in again. I'm going to go to a different layer and start drawing a curve which kind of matches this collar curve. Because what we're creating is a template that we are going to shrink wrap the inside and the collar region of this mesh to. I will look for control point curve. And oh, yeah, remember to turn off OSnap. You don't want OSnap on while you're doing this. You can, I mean, you could use the Blender shrink wrap modifier, but Houdini has a little bit more adjustability with that. So with you can make the attributes. Well, actually, I mean, you could do it in Blender, but it's just nicer to have more of the workflow in one software because we anyway have like 4 or 5 different files in 3 different software. So might as well put as much as possible in one. And also the attribute that is used to shrink wrap it is also used to prevent the texture from being put in the inside of the shoe. So that's also one reason why we use Houdini for this step. Okay, perfect. Let me just duplicate this to a new layer. So I do I've selected the last, right click on this layer, copy objects to layer, and I hide the original and I do 2 NURBS, and that's going to make it into a NURBS object. Did it do it? No, it did not. Yes. Okay. Now this is it's a NURBS object, so we can like cut it and we can boolean it and do all of that stuff, which you can't do with a sub-D. And let me just build this algorithm. Okay, so interface stuff. The double click is to search for a node. So BREP, which means boundary representation, and that refers to the NURBS object. So you don't have to do this step. And if you want to do this step, I mean, it's nice to know this step, because if you make a really complex design with a weird color, then you can use this method to make sure that the color is nice and clean and follows the guidelines. So there's like design guide. There's like color instructions. Look at this. Yeah, check this out. So there needs to be, it needs to have a specific profile. And it's like 5 mm thick, 3 mm height, and it needs to be rounded, and there needs to be like a clearance zone where there's nothing really happening. And with the clearance zone also needs to be about like 5 mm. They're not too strict on the clearance zone, so it's not something that you really have to worry about, but it's a nice to have. So you want to follow these guidelines, and that's why we use this method with Grasshopper. Anyway, BREP, which is boundary representation, which refers to the NURBS last. So I clicked set one BREP, right click, set one BREP, and then it prompts me to select the object. So I selected the NURBS last, hide it, and then the curve, select set one curve. Nice. And what I do is just move the curve. Wait. My bad. I've forgotten what this is called. Yeah. Phi. That's not the one I needed. Unit phi. And let's make it 500. Connect the curve to the G and the T, which is the motion, the translation. So it's moved all the way there. Need that. Bring it back here. And I'll move that curve. Okay, cool. And then loft. So we take the original, and then by holding shift, we drag this one into the C over here. And there we are, done the loft. Split. Oh, what is this called? Split BREP. Yeah, this is the cutter shape. This is the BREP. So now it's split it into two different objects, but you can't really see them because they're still stuck. So it says open BREP and open BREP. So we have to list the items. And here we can choose, okay, index. So it's 0. Let me, yeah. Yeah, so now we can see the 0th item. And I think it's ordered in terms of size. I'm not sure, but is the bottom one. And that's the one that we want as the template. And we can also do outside You know, just look for it. Surface. Yeah, this one. Boolean toggle. Oh, tiny holes in the shoes. The tiny holes in the shoes happens in the slicing level. It doesn't happen in this part. We don't really have to model it. The slicer does that. Okay. Yeah. So we aren't actually going to use this offset, but we just want to know how it will look like on the outside. And usually when you have a curve and you think it's going to be here, but you actually have to lower a few points, like these points. Oh, so lower this point. Usually the curve has to be a little bit lower than you think it is. I think it should be initially, like for the front. What you want to do is imagine that this surface is going to blend into that surface. There's going to be a joining surface between those, which is the next step. But you want to imagine that and try to match that imaginary surface with this. I know it's kind of janky, but this outputs separated surfaces which don't join. So we have to bake this, which is kind of weird, but gotta do what you gotta do, I guess. Oh, okay. So I'm gonna go to the green layer, layer 4, middle click, and click on this egg icon to bake. Okay, that looks great. I'm slightly concerned about this area. Sometimes, sometimes those regions cause issues when trying to join it together. But I'm going to make a new layer and call this inside template. Yeah. I'm going to copy this to that layer. I'm going to turn off the visibility for all of the other layers. Mesh, which will turn this thing into a mesh. So that's a command that I typed out over here. If you want me to do again, mesh. And I go to the more polygons option and click OK. I'm going to make a new layer. Okay, perfect. And I change the objects layer. So now we have this mesh, which we can import into Houdini and use to select the interior points of the of the shoe mesh. Now I'm going to go back to this and to offset. Oh, wait, let me just check. Okay, so here at this point, you want to just check if this is okay. Show edges. And if they only have one naked edge, so one open edge, which should be this edge, it's fine. So it's fine. Sometimes they have little edges over here and here, and that's irritating because then you just have to move the line, the curve, and then bake again and just see how it turns out. It's a little bit finicky. Offset surface, and you make sure the distance is 5, and solid is no, and both sides is no. And okay, the distance is 5. There we are. And let me check show edges. Yeah, looks to be only one naked edge. That's perfect. At this point, I'm going to close Grasshopper. We don't need this. And if you guys open your Grasshopper files, you'll have this. So what you can do is just select this whole thing, middle click and click on this enable. And you'll be able to use it. And you can right click on this and do set one VREP and set one curve. And then click on the curve and click on the last to help you out with that. And this thing we will use later. Okay. Perfect. Now I'm going to double click this perspective button and we can see the, you can see that it's 5 mm. What we want to do is make this blend surface. Let me just check the Q&A. Oh, okay. Okay, so I've clicked, sorry, I've typed blend SRF. And then I click on chain edges. And auto chain is also on. So that's the first edge. That's the second edge. And you want to move this thing, this line that is showing up to the top approximately. Yeah, it looks good. Now hit enter. And it's a curvature blend. You want to keep the curvature blend on. Don't go over to G3, it's not necessary. And tangency doesn't look as nice. And do 0.67. And over here as well, 0.67. And the reason why I'm using these numbers is because I've done a lot of experimentation. And this is just the number that ends up giving us something which is almost 3 millimeters in height. So the surface blend has a height of approximately 3 millimeters, and that's what we want to use. Okay, perfect. Yeah, now you can select all 3 of these and do join. And now it's one closed solid poly surface. That means we're successful. Now open up Grasshopper again, and we're going to do this thing. So VREP. Let me just disable all of this stuff. Yeah, VREP. Set one VREP. And then try remesh. And the reason why we are doing this try remesh and not just meshing it normally is because it gives us more points. And somehow it just works better. I've tried it out with the normal meshing method. It doesn't work that nice. 1 should be the length. So that's 1 mm. And we're up here, and it's going to take a while. It's going to get some water. So there may be points in this webinar that you might not be able to follow along if your computer is not that good. And I pushed my computer to the limit to make the workflow. So there might be spots where that doesn't work out. And in those times, like if that happens, what you want to do is make sure that either like if we're using like a subdivision surface or something, if there's like a subdivision node in Houdini, you want to turn that down by 1. Or if you're using this try remesh, you want to increase the mesh edge length by 1 or 2, how much ever it takes for it to not crash, essentially. But I've tried to get to the best quality that I can. Yeah, okay, cool. We have the mesh. Let me see, someone's asked a question. Why not quad mesh? I mean, you could use quad mesh, but it just takes more time. And it's not necessary because we can just use like, no, this is just a template. It's not, you don't need nice topology for it. Color template. That's the new layer name. And I bake this onto the color template. Perfect. Okay, now we have this template ready. Then we just export these to Houdini. Okay, file, export selected. And you want to go to OPJ. Oh, 10th December. Okay, I saved that. Yeah, I answered this question. Okay, save that. Now, inside template. File, export, selected. I'm going to call this inside template. Inside template, 10th December. Okay, that's perfect. I'm gonna close Blender. Computer specs. I think just check what you need to run Stable Diffusion, because that's the main bottleneck here. I have a 3080 Ti and a i9 12th gen, yeah, 12th gen and 64 GB of RAM. But you can probably do it on like 32 GB of RAM and i7 as well. But the main bottleneck is your GPU, because Stable Diffusion has to run. And you can always like reduce. Okay, I will write it out. But I think it's more important that I just continue with this. And I'll write it out in the end. Where were we? Yes, Houdini. Should we take a break right now? Or how many minutes are we in? Okay, we're only about. Okay, I don't think we should break. I think we should break in like maybe an hour. Take like a 10-minute break or a 5-minute break. Okay, I'll write it up in the chat right now. Okay, welcome. Now this is Houdini, and we have, the interface works like left click is to orbit, middle click is to pan, and right click is to like dolly zoom, so going in and out, zooming. And you can always hit space G and it'll bring you to I think someone asked, how do you zoom to selected? That's in Houdini space G. You might need to use it quite frequently. I'm going to open that file. Synthetics synthetic kicks December 10th. Uh-oh. I have this on manual. So I'm just going to go out of this and let's go to the shoe modeling. And this red slash across the files that you can see means that we've like locked the node. So in Grasshopper, it references the data in your Rhino file, but you can also internalize the data. So you can put the mesh that you are referencing inside Grasshopper. So this means that I've locked the node. So the mesh data is inside this node. It's not something that you have that Houdini has to look for on your computer, which is how it regularly works. So I'm just going to build the same thing side by side, because just in case I get mixed up, I can reference to what I've already done. So wait, again, right click is to get this tab menu. You can also hit tab. That's why it's called the tab menu. I prefer to use right click, and you can find all of your nodes with this in Houdini. And Houdini is like Grasshopper in the way that it uses nodes, and it's like Blender in the way that it works with meshes and not that much nerves. So I'm going to search for file and now look for my file. That's weird. What did I export it as? I exported it. Okay, never mind. Yeah, I was just checking what I exported it as. Okay, let me actually rename this file so I don't. Okay. Export in progress.obj. So the way this works is I'm going to turn it off manual mode. Yeah. The way this works is this is like the, wait, let me get another node in so that I can demonstrate. So I've got the subdivide node. So this is like the template. So you can see the template and it's like a wireframe. And this is like what you want to see solid. And normally when working with objects for 3D printing, you want to make sure that you have flat wire shaded as the default view method. And also something nice to do is to shift S so that the nodes, the wires of the nodes don't look super messy. Like the default is this like straight wires. It looks kind of messy. So you want to just do like shift S and it looks a little bit more clean. Okay, so I've subdivided it. And oh, right. Okay. So first thing, or I think flat wire shaded. Yeah. Yeah, you want to have the wires. So the first thing we want to do is separate the outsole. And that's pretty easy. You can make a group. So type the group node. And you can like put nodes in between other nodes. So I'm going to put both view flags on this node and click on this. So base group means it's going to select everything. But if you choose which ones, or which, by clicking on this, you can choose, and Shift A or Shift would just allow you to click on multiple or select multiple. Group is like a selection, basically. Shift A will allow you to like select loops of them. I mean, select like how control works in Blender. You do the same thing in Houdini. I'm just going to select all of the outsole. Okay, that is great. But we also have to make sure that it didn't accidentally select anything inside. Oh, one more thing. You want to hit space. So like normally when you're in this interface, you can't move around. So you want to hit space and then you can move the, you can like orbit and stuff. But when you're, and then you hit space again to actually interact. And that's how it works. So we've selected all of this. It looks good. I don't see any interior faces. That's fine. It's very common to accidentally select interior faces. Yeah, you hit enter, or I don't know why I had to hit enter twice, but now this selection is like made completely. And let's call this outsole. Ah, there we are. And I think we subdivided, yeah, twice. That up. So the next file that I'm gonna get out is the inside template. And I will also get the color template now. Yeah, cool. So the inside template is this. And if I try to see, looks like we can group those points. So let me just fuse this. So fuse is going to just merge all of the vertices that are like within a certain tolerance. So here's your snap distance. And let's just see. Yeah, here sometimes you can see like they're doubled up. So if you turn on the numbers, display point numbers, you can see that sometimes they're doubled up. But once you fuse them, they're like one number in one vertex. And that's what I did basically. Cool. Or the extrude. So let's extrude this by 1 or maybe 2 and output back. That's going to give us a like closed region. Can we use all of our templates in Google Drive for our own upload or not at all? I don't know what you mean by that. But if you're using the files in the Google Drive, you want to make sure that you just use all of you want to make sure that you go through that workflow separate from this workflow. So this workflow I've made, like I haven't modeled the exact same shoe. So the template is going to be different and other aspects might be different as well. So you want to like treat these as two different shoes essentially that are being modeled. But if you want to use the one in the Google Drive to follow along, go ahead. That's totally fine. Just make sure you aren't mixing the two up. And I will make the back group. Then I'll make another poly extrude. Connect it. And then in this group thing, I can choose, so I can specify that it works on just one group, one part of the mesh. So once I choose extrude back, I can make it extrude this way as well, 2 mm. And by the way, Houdini is also in meters like Blender, but since the last is in millimeters, we're just going to pretend that the meters are millimeters. I know there's some way to fix this, and there's a way to like actually make it everything work in millimeters, but I just haven't done it yet because it hasn't been a good use of my time, I guess. Group. Let me see what I call that group. Inside. Makes sense. I'm going to call this group inside. Turn off base group. Keep and use keep in bounding regions and change this to bounding object. This will be the bounding object. It's the bounding points. And make this points. And now you can see all of these points have been grouped. And what we want to do is just go around the outside and make sure none of the outside areas have been grouped. Cool. This makes sense. Distance along geometry is the next node that we need. And you choose the start points as inside and outputs the attribute dist. Let me just check. Yeah. Oh, inside dist. Okay. Yeah, there's going to be many dist attributes, so we got to categorize them. Okay. Now we can try to visualize this attribute. This is actually quite fun. So this is how the attribute has turned out. And we don't want that. We want to remap it. So to remap something accurately to a specific range, we need to know the maximum and minimum. And we're going to get those maximums and minimums. While you can always use this, and we can always get it like, okay, original name inside dist, compute range, and then go from 0 to 1. But what if you change that? Like, what if you change the color or something? So to make this like truly procedural, you want to get the minimum and maximum automatically, which is what we're going to do now. So we'll get attribute promote. Original name is inside dist, and new class will be detail. So detail is like, okay, wait, let me open this up. This is a spreadsheet where you can see all of the attributes and like which point number they're associated with. So these are the point numbers. And then you can see, okay, these are what these point attributes. I'm gonna uncheck delete original so that we can see them. See, it goes, you can see the full range from 0 all the way up to 230. And there are vertex attributes, which is like UVs, and there is primitive attributes, and there's detail attributes. So here it's got the average, we want the maximum. We got the maximum, and I'm going to click change new name, Control C, Control V, and then just write max. So inside dist max. That's great. You can get a minimum as well, same way. Go here, minimum. So inside dist min and inside dist max goes from 0 to 230. That's great. Now when we go here, instead of using these static numbers, we can input an expression which gives us the minimum and maximum. Any questions? Okay, cool. Let me just get that expression out. I think it's bad. Detail 0, comma, and we have to use these like, oh, space here. Space and these like double quotations. So not the single quotation, but the double quotation. Inside this min, close double quotation, comma, 0, close bracket. And we'll see if that was correct. I'm going to copy this, Control C, Control V, and then just make this max. Okay, it worked. Now what we can do is choose how far that attribute goes. And this is how we create the shrink wrapping. So someone asked a question, why don't we just do this in Blender? Because we can get this kind of control with Houdini, and we can use these same attributes for further steps in the process. Okay, that's cool. And we want to also blur that attribute. Blur. So by default, attribute blur will blur the point, the position attribute, which we don't want. Instead of that, we want the inside dist attribute to be blurred a little bit. Let me actually move this up. Yeah, okay. Okay, I've blurred it like a decent amount. So what happens if you bring it down here, then it doesn't really stick to the last perfectly sometimes. Let me see if it looks nicer if it's smooth. Okay, cool. So ray is like the same thing as shrink wrap in Blender. And what it does is, let me see how I did that. Oh yeah, scale. Use minimum distance. And first when you do it, it's just all gonna shrink wrap. And you can see the blue is like the template geometry. So here we can use at for attribute inside dist. And oh, that also means we should go from 1 to 0. Yeah. But as you see, it isn't perfect because in some places it's like that, and in some places it's much closer to the template geometry. So what we need to do is subdivide it and then shrink wrap and then subdivide and then shrink wrap. Oh, okay, never mind. I thought the template geometry was like peeking through, but it's fine. So what we need to use is a loop with feedback. So for loop with feedback. And what we need is the ray and then a subdivide after that. And we will set, before we actually do this, we'll set this to like 3 maybe. Let me see, how much do I set this to? Yeah, this is set to 3. Now check that out. It's shrink wrapped it completely. You can click on this like location looking thing to turn off the visualization, and also template view the color template so that you can see how close it is. And it looks pretty close. It looks to be very, very close. If anything, the color template is making it less smooth. And at this point, if you don't have a PC that, or if you have a PC that might not be able to run this very well, what I suggest doing is keeping this at, instead of 3, keeping it at 2. And it won't affect it that much, but it might be just slightly less sharp final result. But I'm going to keep it at 3. But if you think that because there are quite a few future steps, if you think that it's better, keep it at 2. And we have one subdivide at the end, just to make it a little bit smoother. You can also not do this if you think it's not, it would not be good. Okay, what's next? Yeah, remember the outsole that we grouped? Let us isolate that. Delete. So delete is like you isolate a specific part and choose the group. Instead of doing delete selected, click on delete non-selected. And we're basically going to do the same thing, except without any attribute. And we're going to use this as the shrink wrap object. So like I said, same thing as this. You can just copy the server. In the ray, turn this off, delete this. Oh. How do you do that? That is super weird. I'm just going to replace this. Okay. Some things are a bit iffy over here. Okay, this, what you want to check is like, oh, so something. Okay. What you want to check is like the edges or see if there's like any weird overlaps, and that is something that happened. And also, why is this not perfect? So what I think needs to happen is the shoe mesh needs to be edited. So I'm going to go all the way back to the original low poly and click on this, select, and select these three, and then click on move. And what that does is it creates an edit node. Can middle click on this and click on align handle with world. Oh, why did it do that? That's so weird. Okay. Anyway, let me just do that again. Okay, it looks a little bit nicer, and hopefully that will result in a, oh, let me just explain how I did that. I clicked on select primitives, so this, and then clicked out of there and hit space. So that's how I exited the edit node. I think you can also hit escape or enter. But let's see how it ends up. Okay, yeah, no issues this time. There's no like weird overlap. No, but there is something weird about this part. Let's see what's going on over there. Oh, okay. In this selection, I have selected. It's about the same, so I think we can let that slide. But basically what's happening is not the entire shoe is not being covered by the outsole. And if you really wanted to get into it, you could go here and you could do the same thing and edit this so that you could bring those out and like bring this side out a little bit more so that it covers more of the shoe, but that isn't really necessary. Okay, perfect. Let's just give it normals. Normal. So this is just like fixing any weird normal issues that are there and that are very prone to happen. Okay, so here what we do is search for a null. And in the null, you rename it out. So I'm going to write 1 because we already have an outsole. And I'm also going to write out. Okay, that's great. Okay, now in the outsole. Uh-oh. Okay, that's fine. Let's just make a copy of that. Let's just do that. Yeah. So I just typed in geo. So wait, let me just explain. I went up a level. So in Houdini, there are nodes within nodes within nodes. So I went up a level by clicking on this. And here's here's the other nodes in the file. So I'm making another geo node by typing geo. And here we have it. Let me call this outsole 1. And I've double clicked to enter. Right click and search. Where is it? Object merge. Yeah. So here you could choose, you can bring in geometry from a different node. So I can choose from shoe modeling. I can choose outsole 1, accept. Then I make a null. Let me just check what I call that null. So out 1. No. Outsole out work in progress. Let's call it that. And the reason why we have this is so that we can render the depth of this to use as an input in Controlnet in Stable Diffusion for the texture. Okay, what is the time right now? Okay, I think we could have like a little bit of a break because we've gotten we've almost reached the AI part, and like we're halfway, I would say halfway through the main part of the webinar. So I'm just going to give it like a 5-minute break. But yeah, if you guys have any questions, feel free to shoot them. I will answer them right now. Like now is a good time to ask questions. And if you want me to go over anything which I didn't go over, or if you didn't understand something, I can like answer those or go over those parts again right now. What other models other than SD have you tried with this process? So like last year, we tried with DALL-E in painting, which was kind of bad. I'm just gonna get like a quick snack. And I didn't use Houdini for it. We used what's it called? Hyperganic, which which also has a displacement texture thing, which is kind of where I got the idea from, and we developed this work a little bit further. Then using Houdini, and then finally integrating everything in one thing with MLOPs. Do I have any favorite books on shoe design, industrial design, general design? I'm not sure, honestly. I really like algorithms aided design. Is that it? Aided design. Yeah, by Arturo Tedeschi. That kind of got me, made me understand Grasshopper a lot better. Just generally design, I like Virgil Abloh's Icons. I'm sure it's a pretty common book for people to like. I've actually not I actually haven't read books in a long time. um, oh, and Larry Oxman's book, Material Ecology. Oh no, that's not no, that's not a book's name. What is her book's name? Oh no, it is a book's name, but it's like called Catalog. Um, there was another one. I think it's called Do the Gods Wear Shoes or something like that. Let me see. Do the Gods Wear Shoes. Nope, that's not the one. I'm just Googling this. Did the Gods Wear Shoes? By William Habraken. I'll just check that out. I'm glad. Okay, someone said, I know that you were a Mac user. Oh God. There is a way to install MLOps with Mac. I have not tried it because my Mac is really old and I know it won't work. But I'm pretty sure that some M series MacBooks will be able to use it and be able to run MLOps. I would suggest you check the Discord, the MLOps Discord, and like ask people. I know someone has been able to install it on Mac over there. Am I gonna organize another webinar? I don't know. I mean, if people want me to, I would be interested in doing that, but I don't know. What PC brands do I recommend you build your own PC? That's what I did, and like I got really good value for money that way. But I think it might be the best to just build your own PC. Asus parts are the best, but they're expensive. I think there's like a ranking of which GPU manufacturer gets the best chips, and those are the ones that you should buy. Like Nvidia's Founder Edition series gets the best, and then Asus gets the second best, and then I don't know, MSI. So I have a feeling that we might have enough time for me to get into like the slicing and like the printing recommendations. So I'm pretty excited about that actually. Hopefully we can reach that point. And once we cover that, if like everything is fine, then we can also like see if we can do a render or something on in Blender. The renders are usually the most like demanding part because you render the G code, which is converted into an OBJ. All right, okay, let's get back to it. Where were we? Oh, yeah, setting up the cameras. Okay, now I've made the main shoe visible. And I'm going to set the view to front, which is actually going to give me a side view. And I control shift. Well, my keyboard just went off. 1 second. I gotta plug it in. Okay, cool. So now that we're in the front view, which is actually the side view, control shift click the camera, and it'll make a new camera. And yeah, here you can go to the view and make the resolution 512 by 512. Okay. Let me check the other cameras. Yeah, that's 512. So I think with SDXL, which I don't have installed and I don't recommend you use for this webinar, I think SDXL works with 715 or something like that. You'll have to check it out, but I don't recommend you use SDXL because the Controlnet models are kind of mediocre. Right. Right. It's because I think Controlnet depth is not that good or isn't there for SDXL. Okay, so now that we've reached the stage, go over the ortho width and hold down the middle mouse button and just like drag a little bit. Oh, that's too much. Nope. Okay, I'm gonna reduce this. You want to just about fit the shoe inside the thing. And you can always move the camera a little bit. Make this 330. 325. Okay, that means I think I can move it to the left. So now I can move the camera. So in Houdini, it's like X, Y, and Z. So like this one is X, this one is Y, this one is Z. So I can move this 325, let's see. Okay, 20. Perfect. I think this is as good as it's going to get. And now these cams have already been set up to render the bottom side and this and the left side like this. By the way, have there been any interruptions in the webinar so far? Because sometimes I can't tell when like I get cut off, if I've been cut off at all. Okay, I'm gonna take that as a all good. Okay, we got this camera. Okay, Oh, okay. I didn't mean to do that. I opened this and now it's gonna cook. Whoops. Okay, so what's happening here, uh, if I can explain it, is we are making prompts and those are going into tokenizers, which is kind of parameterizing words, if that makes sense. This part does the parameterization of the words. Then this is noise, and I've linked the noise up to the frame in the video. Sorry, in the animation. So if you move from 82 to 83, it's going to generate a new pattern. And this is the control net. So it's getting it's using camera to points. So it takes the shape or the depth and it makes a control net out of that. And it solves it and decodes it into an image. And then it makes, then it puts it in a texture editing, I guess, environment. And it puts that texture onto the side of the shoe using a UV projection, which happens, UV is like the way that you, I guess, put textures on objects. So it projects the texture mapping from the camera. And same thing happens with the sole. The sole is done separately and that gets transferred and we get like a textured object. So let me just make this from scratch again. Prompt create. So let me just check my prompt previously. And prompts do matter. So got shoe with ribbed texture, parametric, inspired by dinosaur bones, segmented, diatoms, mechanical, skeletal. And here's the part where you can have fun. Make your own prompt or use this prompt. And I thought this was a nice, it gave me like reaction diffusion-y kind of patterns, which I always love. And it also has a bit of a HR Geeker vibe without using his name. So I'm going to use this prompt because I know how it turns out. But you guys can choose whatever prompt you like. And in the future, when you're making textures for your shoes, you can use the design direction of your shoes, or you can take pictures from your mood boards, stick them in this thing called clip interrogator. You just get clip interrogator. Yeah, this is amazing. Stick them in clip interrogator, stick them in let me see if I can upload an image. How do I make them? Yeah, suppose I want this shoe. Oh, this is going to take ages. Okay. Get it, but basically it's just going to give us a prompt. We just run that through GPT-4. That'll be faster. think this would be nice. Describe this image using this image. Yeah, see, continuous, wavy, rib structure, fluidity, digital and parametric design, computing. So clip interrogator does the same thing, although it's going to take ages. But yeah, you could use these. But yeah, cool. Okay, anyway, let me just go back to the perspective viewport. And let's start building this prompt out. This is the prompt I'm going to use, but like I said, mess around with clip interrogator. Oh God, it's going to run it again. That is a good reminder for me to just save this file. Okay, perfect. So in your second prompt, in the first prompt, let me just get the first prompt out. In the first prompt, you want what you actually want. Get that here. In the second prompt, you want to just write all of the things you don't want. And that's going to be the negative prompt. And then next. Oops. Yeah. Encoder, tokenizer. Yeah, tokenizer. And here's another important thing. Go here and change this to Stable Diffusion 1.5. And same thing. All of them, whenever you see like tokenizer model or whatever model, you want it to be V1.5. Text encoder, again, 1.5, compute device CUDA, that's good. Negative prompt here. And yeah, latent noise generate. So what we did was, yeah, plus $1 plus $FF. So 1 plus $sign FF, sorry, capital F. So $sign FF is the frame value. Enter. And we also get the SD scheduler. SD scheduler. Once again, Stable Diffusion 1.5. And if you haven't already done like the downloads of these, it might take a while. You might have to uncheck this, wait for everything to download, uncheck this local cache on everything, wait for that to download, and then check local cache on every single one. And while you're doing that, you want to turn off auto update. So you, while you are rechecking local cache, that is when you want to turn on auto update. What current visual language AI model is your probably ChatGPT. right now. But I don't know actually. I mean, I use ChatGPT a lot. But I think that now Gemini might actually be better. I haven't tried it yet and I haven't gotten access to it yet. Oh yeah, latent noise. So let's actually take a look at this. Yeah, there they are. And you can see they are just points. And this is how MLOps works. It stores all of the matrices on these points that basically work to do stable diffusion, to do the matrix multiplication that is stable diffusion. Cool. What else is next? Yeah, the Controlnet. Camera, 2 points. Let me look for, we need cam 3. Scene path, OBJ, objects to render. Ah, now I remember. I am going to duplicate this. I'm going to click ignore visibility flags. And I will choose shoe modeling work in progress. And let me just do this and look at how it turns out. Oh, that's weird. Update node is manual. View may be out of data. I didn't realize it would do that. That's funny. Oh, it's measuring shading. We need depth. Let's do that again. Okay, perfect. Cool. You can also mess around with this stuff, but I don't think it's necessary. Let's so I've added an ST solver and I click on attention slicing. And here's something fun. If you have your own LoRa trained, like a fine-tuned version of Stable Diffusion, you can actually use your own like weights. So it can be your own aesthetic. If you've trained, I have a Stable Diffusion model trained by Luis, not Zellerfeld's Luis, but Luis of Rosa AI. He trained a model for me, but that's on Excel, and Excel doesn't work well with Controlnet. So unfortunately, we can't use that. But if you have a model or if you train a model, there are many websites where you can just put in a bunch of images and get your own model trained. If you do that, you can add those weights over here and you can like play around with the scale and stuff. It's actually quite nice. Oh, Controlnet create. Controlnet create. Is that the right one? Yeah. And you want to choose Controlnet depth. Okay. And image encoder. Okay, let me save this and let's see if it worked. Oh, scheduler latent noise. Why is that? That is super weird. Let me see what happened here. Unplug and replug the wire from latent noise. Okay, let's see. Okay. Thank you. That actually did work. I was so surprised. Ah, I think I know why that happened. Because when you turn it on a manual update, it doesn't update the noise. Okay, this is kind of nice, but I don't really like it that much. So, yeah, something that happens sometimes is that when you turn it from auto update to manual update and then back, it throws you a bunch of errors. And the way I was doing it earlier was just reopening the file. I like this. But I think that what Giorgio said was a better method, unplug and replug the wire. Okay, I'm just going through the frames here and seeing what we get. This one is kind of cool. This one could be really interesting. I think, yeah, let's go with this one. It's already kind of got the color figured out, so might be nice. Cool. Now we can just copy. What do you click to run the prompt? So what I had to do first was unplug and replug this wire. And because I had 1 plus $FF, every time I move the frame, and also because I have auto update on, every time I move the frame, it regenerates a different, using a different noise. I'm wondering if anyone has success running Stable Diffusion. And not sure, but I know that Comfy UI has some sort of Mac implementation. Okay, anyway, I'm gonna go with this. I'm gonna put it back on manual and hope that doesn't break. Let me copy that over. Oh yeah, I need to set up the other camera. And put it back on auto update. You need to pay the, no, you don't need to. You can, if you have a GPU that's capable of running it, you can run Stable Diffusion on the on your own GPU. But I think there is a way to like use your API key and everything if you don't have a good GPU. But I think it's just much better to just invest now while they are cheaper, I guess. Set view bottom viewport. I'm gonna zoom in on the shoe a little bit more. And again, shift, control, click. $512. Oh, you can actually move it around like this. My bad. I think we went with 325 last time, right? Yeah, this one is also 325. I think it makes sense that they should both be 325. And this looks good. Let's get back to the main texture. Oops. First, let me choose. Oh, wait. Best. Yeah. And I will choose Cam 4. Oh, that does not look too good. Why is that? This is strange. One second, I'm just going to compare it with the other output. Yeah, that is much better. I have no idea why that happened. Well, I think it's because the outsole doesn't have much depth difference. like in comparison. Yeah, there's way more depth difference in this outsole. So I guess it just isn't picking up as much, but that's fine. Also, why is that outsole super subdivided? Oh, they repeated that 7 times. Well, it's fine. It's not the best, but I guess maybe in the future, or for your own work, just make your own shoes have a little bit more depth. Like you can see the difference between the example version and this version. It's a pretty big difference. Oh, and of course, shoe modeling work in progress. Okay. Okay, so what I did was I just switched the thing. I switched the object merge to this one instead of this one. And it generally looks better. Let's see how it looks on the Controlnet. Still about the same. Let's see, maybe we want to edit the shoe a little bit more. Because I think that it isn't, I think that it might not be as exciting. Um, okay. Okay, now that looks a little bit more exciting. Um, let's see if it results in something a little nicer. That is so weird. Why is that happening? Um, hmm. Maybe, yeah, it's something to do with the camera. What has it got to do with the camera? Oh, it's so much closer. Okay. Yeah, okay. Now it's better. Ah, phew. I think that back end is fine. But it was because the camera was really far away. So what I did was I just went and I copied the Y value, which is the vertical value from this camera over to this one. So it is closer. Cool. Let's see how it turns out. That is super interesting. I use the more traditional last, and I suggest you use that last because it has a nicer toe box. Okay, that's how the sole is going to look, and that's how the side is going to look. Nice and cohesive. I think the design language is not that varied. Although the depth would be different, like the depth that it gets extruded to would be very different because the contrast is like very different in both of these. On that contrast topic, it might be better to just try out a different frame. Let's see. Yo, that is sick. So you can actually get a lot more crazy with the texture on the outsole than on the side. So I think this is fine. And the next step of this would be to make something which would oh boy, yeah, looks like we should run a little bit faster than this. But the next step of this would be to make an algorithm which measures the overhangs and then uses that to influence the texture displacement. So that might fix some of this contrast being too much as an issue. But yeah, let's see. Okay. Now here's a part where it usually crashes. So that was a cop2 network. So you search cop2 network, and that's what that node is. And then you do import color points. SD image decoder 3. Okay. SD. Where did it go? Oh, it's in main texture. Will it crash? Okay. Yeah, both Pedro and I had issues while trying to run this file. And that's why I had to split up my file into like several different files. God knows why it's running it so many times. Okay. But this cop2 net3 import colored point step was a big issue. Let me see what I called it in the other one. Out. Okay. Wonderful. And I'm just going to copy this over. And change that 3 to a 4. Simple enough. That's great. Now it's time to actually get the shoe in and texture it. So object merge. And we choose shoe modeling, work in progress, out 1. I think it's UV. Oh, no, actually delete. And we delete the UVs. That's it. Oh. I actually don't know if this is fully necessary. Let's see. Let me see what other attributes are here. Oh. See. UV. Okay, I've deleted the UVs and the material path, although I don't know if that was fully necessary. Let's see, where'd it go? UV inject, I think is the node. UV texture, okay. UV text. perspective from camera. And then we choose which camera is this, cam 3. Accept. And let's turn on the UVs. What is this? Is this UV? Yeah. So now you can see there's a huge amount of stretched texture across the entire toe box. And the outsole is like also super stretched. So these stretched areas are something that we're going to deal with later in a different file, in the next file. But we'll deal with this part first. Attribute from map is the next node that we need. And this is also another one of those weird syntax things which I didn't know about until very recently. I'm just going to copy this and also paste it in the chat. So what this is doing is it's just reaching out and getting this thing. So you'll have to modify it a little bit. Texture channel. Cop to net 3. Oh boy. Did it crash? Oh no, it didn't crash. Wow. Wow, that's pretty cool. That is actually genuinely cool. Okay. If you really want to see the texture properly, you can just go to flat shaded instead of flat wire shaded. Looks good, I think. Okay, now we can do the outsole. So that's just going to be like here instead of this. Go to outsole 1. Accept that. This is fine. This is fine instead of this cam 4. Instead of cop2 net 3, cop2 net 4. And yeah, let's just check this out. I think what's happening is that when it goes from like the normal environment to cops, like the geometry environment to cops, cops is like compositing operators. I think. Let me Google that just to make sure I'm not telling you guys something wrong. Yeah, it's compositing. Okay, thank God. But when it goes from this back to cops and then back, it like it takes a lot of the computer's memory. Looks pretty good. Yeah, cool. with transfer attributes from this to this. Oh, no, we don't need to worry about this. And you go to conditions and make that distance threshold like 1 or like 3 maybe. Okay, and we're just going to put this on auto update again for a bit. And let's see if I can get the distance threshold down. Okay. So you want to find a number where it just about has the texture, that all of the texture that you generated. Honestly, this looks kind of cool. But for the sake of doing the webinar the way I meant it to be, let's just find that number. Okay. But you also don't want it to be too much, because if you can bring it all the way up, you see it kind of stretches on the side and it doesn't look that nice. So I'll go back to 0.43. And you can also change the model and stuff. And like, I think like the further away you get, okay, 0.5. Yeah, the further away you get from like the first one, the slower they get. But it doesn't really matter that much. It's not like a huge difference. This looks quite cool. I think this is now exportable, right? Yeah. What should I call this? Out for it. Okay, that is perfect. Let me export this, save geometry, and I'll go to my documents, webinar. But I will make sure that I save BGO. And I want the BGO file type, because it's a really it doesn't take as much space, but it saves all of the attributes, and I'll use the attributes in the next file. So I accepted it, and now I guess we can have a little break. I'm gonna get some water, and if you guys have any questions, I will answer it. If it crashes, how can we get that recent file back? You can go to File, Crash Recovery, Open Crash Directory. Then you can find your file over there. Then once you click on that, then you can, like, once you click on that, then you can go to Open Crash File and you can get it. Sometimes it doesn't save when it crashes, and then your file is just gone. I don't know how to help you when that happens, and I wish I knew. But that's kind of rare, and it doesn't happen that much. But anyway, you should just save frequently and save as many versions as you can. Would you mind having the PC Task Manager? Yeah, sure. I would do that. Okay, I'm just gonna get some water, mute myself, and I'll be right back in 5 minutes. Okay, I'm back. I'm just gonna look at all the like questions and stuff that people have said. Can't get it to run inside Houdini. Yeah, that's true. Oh my God. The installation of MLOps is a pain. Go to the MLOps Discord. I've already sent the link, I think, a while back. I can send it again right now. Let me do that. Sure, I'll just show the cop setup. 1 second. This is the MLOps Discord. Go there, ask your question, and I think that or search the Discord and see if someone else had the same question. Because I think some things would some errors would repeat. That happens quite frequently. Yeah, I'm using 19.5. I haven't upgraded yet. And I think that I actually haven't updated my MLOps in a while. Like I don't have Stable Diffusion XL. My cop would update erratically. Can I show the cop setup? Yeah, I'll show you the cop setup. 1 second. Here's the import color points and an out. And then I do have Git installed. I don't know if you're asking me that. No. And okay, cop. Nope, none whatsoever. No method mesh, plane, XY plane, sampling, center, uniform scale. Can you try to run the file? Try to download the file from the Google Drive or Giorgio and just try running that. Let me get my Google Drive out. Yeah, try running the file from this Google Drive and see if it works. If the COP network works. And maybe you just want to copy paste the COP net and the attribute from map part with the OP full path thing. Yeah, the texture map part. Yeah. Yanis, yes, that would be a great idea. And I guess you could maybe set up a pipeline from Blender or into Blender. I don't know how that would work, but what are everyone's ideal dream? I mean, what's the best computer that money can buy? Okay, I'm gonna get back. All right, we saved the BGO. That's great. We're done with this file. And I would suggest just keep it around in case you want to mess around with it. Ooh. I'm gonna save this and then close it. Oh, that actually reminds me. I'm just gonna stop sharing for a second. Just give me a second. I'm just looking through some files which I don't want to show on my screen. That's why. I've just added a new file to the Google Drive folder called the Zellerfeld walls cutting.hiplc. That one might be useful later. I think we might have time to use that file. And even if we don't have time, I'll try to just stay awake and explain how to use that file. Oh, sorry, I closed Task Manager. Oh wait, how do I? Okay, now I'm going to share my screen again. Yeah, cool. Now this is a complicated one. So let me just explain the flow of this file, and then we'll get into building it. So what happens here is this was the shoe from the file. We calculate the UV distortion. And basically we're using the UV distortion plus a bunch of groups. Well, we can't see it yet. But we use the UV distortion to section out the mesh. And what we do is we delete it and we get just the distorted parts out. And then texture this from the top. So we basically take that bottom camera and flip it around. So we texture it from the top, and then here comes the important bit, where we transfer that attribute onto the original, then we turn it around, and we let me show you. We turn the mesh around so that it's in the printing position, and then we start looking at overhangs. And we also export it after texturing it, export it to Blender, like after displacing it, export it to Blender, find the overhangs in Blender, like separate the regions which have overhangs in Blender itself, so that there's like 2 steps in this process. And then we blend the shapes, like we use that distance to give us more fine overhang removal. And then is like all of the exporting and poly reducing, like reducing the density of the polygons and stuff. And yeah, stuff like getting the closed walls, getting the shoe, getting the last. Last is like pretty easy. All right, so let's build this setup. The first thing we need is the file. And this is pretty easy because there's just the color shoe, which is like, we've just brought that shoe in anyway. And you see the PGO file has preserved the texture, the CD attribute, the color of each point has been preserved. Okay. All right, distortion. Okay. So the same way we use the distance, the inside distance, we promoted that to a detail attribute. So detail means like the whole object. So the same way we promoted that from a point attribute to a detail attribute, we'll do that with this. Minimum. Oh, right. Oh, it's a primitive. Primitive. UV distortion. UV distortion min is the primitive attribute name. Maximum UV distortion max. Perfect. Detail 0, comma, unquote, close double quote. Okay, now let me just check if that worked out. Geometry spreadsheet, primitive attributes. Yeah, looks like, see the minimum, so minimum is 0, maximum is 1. That's how we know this worked out. Cool. What's next? Yeah, these attribute triangles. So what's happening here is we've made a threshold for the UV distortion. And we are grouping anything below that, sorry, bigger than that threshold. No, smaller than that threshold, my bad. I'm just gonna copy this. So you want an attribute wrangle. So I at group top is makes a group called top is equal to UV distortion smaller than certain threshold. And then you have to click this, which will make that threshold. And CHF makes like the slider. And let's just check what the threshold was, 0.95. All right. Now we can, oh, this is to run over primitives. Yeah. That's strange. Yeah, that worked. Oh, right. Because these are flipped. Yeah, here we are. So what I had to do was flip the 1 to 0. Instead of being 0 to 1, I changed it to 1 to 0. But you could have it the other way as well. That's also doable. And now we have to make another group. What did we call that? Inside. Yeah. Okay. Delete. Non-selected. That's weird. Oh, it's the other way around. Okay, I switched the greater than sign to a lesser than sign. Okay. That looks good. So what's happening here is that we're making separate groups. It does. I'm not sure what you are referring to. I'm not. So what's happening here is that we're making different groups. Oh. And we're choosing, like we're making the inside group, and then we'll use the outsole group, and we'll subtract those groups from the UV distortion group to isolate that region. Group remote. Yeah, we want the inside group to become a primitives group. And let me remember how the outsole one went. Oh, right, the outsole group is already there. Is it? Outsole is already there. Cool. Let me just check. Yeah, it looks cool. Group combine. Yeah, this is also kind of funky with the combining part. Let's see. Okay, group name top equals top subtraction with inside and subtraction with outsole, and we are left with just this. That part actually looks like it's going to get some more texture stretching, but can't fix everything right now. And I also think I want to increase that threshold. So I will go here. Oh. Okay. Yeah, I was just trying to cover that region. Okay. Okay, I think that's fine. Okay. Cool. Now I'm just going to make a copy of this. So object merge. Out distorted 1. Work in progress. Oh, that actually reminds me to add a color. Yeah, because this time we're going to use the color, not the depth. And we'll have a different setup. So you can see over here, we're using in painting. Oh, my bad. We do use the depth. No, do we? No, we do use the, I'm not sure. No, we use the color. Oh. Okay. So what we're going to do now is in painting. Let me see what my prompt was. Kind of the same as the previous one. And this one was, yeah, same thing. So same thing as last time. Prompts go into tokenizers, go into text encoder. One prompt is negative, one prompt is positive. And that goes into the scheduler. And I think this time with the latent noise generate, oh, I did the same thing. No. One plus sign f noise. Oh, right, the camera. Let me just open the previous file and I will copy that camera into this. 1 second. I will save this first. Just so y'all can see that's what's happening. I don't know if I should just let it go or should I? I'm gonna wait like a minute and a half to see if this continues. And if it doesn't, then I'll just close the task. Oh, wow. Oh, okay. Wow, that took a long time to load. Um, let me just drag cam 4 out of here. Just make sure that's the right camera. Yeah, that's the right camera. Copied it. And okay, perfect. You can see, you kind of tell where cam 3 is and where cam 4 is. Switch that for a plus sign. And this has to also switch for a minus sign. So now we go to cam 4. Perfect. Okay, this started work in progress. Okay, that's for the in-paint thing. So now it's rendered a mask. So it knows, so the way inpainting works is it figures out, it uses a mask that you input. So we've got this as a mask. And it figures out what should be inside that mask. So the other thing that we have to get is the main colored shoe, which I guess we can also have an out. Null. And we have to make another one of these. So geo color object merge. That's wrong. Color shoe open brackets. Oh no, what did I do? Whoops. Well, I'll bring this back to 3. Okay. Now this has to go through an image encoder. Or let me just make sure everything is 1.50. Yeah. 1.5, 1.5, 1.5. Oh, actually, let me close this file. Yeah, okay. Cool. And turn on attention slicing in the solver. Image decoder. Oh, that's cool. Okay, so now again, like with the previous one, you can just keep going through and seeing what it comes up with. Nice. That's interesting. Too weird. Kind of okay, not that great. Yes, you can leave the part blank. I mean, and if you really want to go into it and edit it, you can actually use the attribute paint node. And I can show you guys that later if we have time in the very end. I will like show that off. But you can leave it blank also if you like. Or you could just project the colored. I mean, you could attribute transfer the color from this version, which is this white colored version. And that could just be the color if you like. But I think this is a little cooler. I mean, okay, I'm just going to settle on one. I'm going to settle on 4. I think I like 4. What did I like? Yeah, you know what? I think this is cool. I think I'll use this. So same thing, UV texture, perspective from camera. I choose cam 4, accept, then sorry, I'm just trying to kill a mosquito. Attribute from map, attribute from map. And we use that OP full path syntax. Oh, we need the COP.NET, my bad. COP.NET. Import colored points. COP.NET2. Okay. Okay, I was just turned off the visualization for those other nodes because I didn't want to get distracted. The front looks a bit gross. This back part actually looks kind of interesting and cool. But if you wanted, you could just infinitely add steps to this and select different parts of the mesh using attributes and that attribute triangle, which does the threshold selection. And you could basically divide up the shoe mesh into several different sections that you texture separately using in painting. So if you wanted to get a perfect toe, you could do that, or you could just attribute paint it, which I will show you later. Oh, yeah, here also you have to make sure that you change the radius of the attribute transfer node. I guess now you can see how drastic the texture change would be. And this makes me think that this was not the right choice. So let me go back to 4. That is very drastic. Yeah, let me just check out this because I think that's so weird. Oh, I understand. My bad. I was getting it from the other one, from the wrong one. I had put 3 thinking that this was the correct image decoder, but it was actually image decoder 1 that I was supposed to use. And that's why, yeah, that's why it looks so weird. Go back to 4. Nice. Now that actually looks cool, except for the front, which looks horrible. But it's too much of a pain to really go through and fix unless we have more time. Okay. Now we can get into the real fun stuff, I guess. Or not. Well, now we can get into the texture displacement and the overhang detection stuff. But at this point, stuff isn't going to crash very easily. Your file is safe. It's still good to save. Ah, so what's happening here is that we are changing we're changing the color using the inside distance. So I'm going to use multiply. I don't know when they'll be available. It takes a few days usually, in my experience. And the mistakes will be there. uh, Float attribute. Yeah, there we are. So later on the algorithm, when we displace, the white parts will be displaced more and the black parts or the gray parts will be displaced less. And we can also like fine tune this so that it goes a bit more like that. Yeah, I think that looks better. Oh, wait. Nope, that's not it. Yeah, okay. So now I've rotated it 120 degrees. And this part is a bit stupid because there's a way to do it by rotating the vector, but for some reason when I made this part of the algorithm, I was making it for a different project and I didn't really know what I was doing. So I just did it this simpler way. But it does have its advantages that it's rotated this way. So let's just get into it. Whoa. Okay, 1 second. I'm just going to delete all the unnecessary things. Um, Okay. So what's happening is that we are comparing getting the dot product between this vector and we're putting that into an attribute called overhang. So let's write that. So this is like a node within which there are nodes that you can manipulate points and their attributes with. And that's what a point pop is. And there is like attribute pops, which are, I think is the same thing as a point pop, but there's less to do with points and more to do with just the attributes. And there are volume pops where you can deal with like densities of volumes, and you can get quite cool results out of them. But anyway, oh, whoa, that was unintended. Okay. So dot product is, okay, someone's asked a question. Composite textures, hands. Yeah, you could do that, and then you could import the image. And instead of doing that OP full path syntax, you could like click on it and then manually choose the image in your file browser. Let me just show you how that would work. So say you would go to attribute from map. Instead of writing this, you would go here and you would choose like an image. So you can do manual compositing. That's actually the way that that's the way that I was doing it before MLOps came out. So what was that node called? Sorry. Component. So that's the normal of each point. Overhang. Okay. Oh, just make sure that's right. Okay, that's about right. visualize. Okay, now we want to see the overhang. Okay, now you can see that some regions have like red and some regions have green. And the red parts seem to be like more in line with the vertical. The normals seem to be aligned with the vertical areas. All right, yeah. This part is the most confusing because we're taking the -1 to 1 and then bring it to 180 to 0. And that's so that we make it an angle. We're not to visualize. All right. So we're getting the overhang and we are clamping it. So that means we're basically creating a cut off of values. So we cut off values between above 45, we don't care about those values. So this is just getting that attribute in. Okay. That is super weird. Oh, no. Because it's a float. There we go. And let me just get that previous find export. Cool. Overhang. Let's check the geometry spreadsheet. Point attributes. Is it a this attribute? What is it? Cool. I'm not sure why I did this, but I think that it's I think that this I just like adjusted a lot. So I'm just gonna copy the node over. Oh, no. Strange, but whatever. Okay. So I've blurred out the color again. CD is color, by the way. It's mostly to kind of fix those seams and make them less visible, but it also makes the displacement a little bit less sharp. Okay, now we're going to do the displacement. Base along normals. So we're taking the color, which is a vector, and just making it a float. So that's just one number instead of two. That's instead of three. And we're multiplying the overhang by the color by a constant, which we will make 2. And then we will displace the points along their normals. Uh-oh. 0.2. Wow. What went wrong? It might be here. Venomous entered the chat. Lol. I have a feeling it's here. Let me just clean this up once. Yeah, this looks significantly less lengthy. Oh, obviously. I'm so stupid. Here we are. Here we are. I'll make that too. And put the normals back on it. Okay, now this is looking more like it. Let me also make sure that this overhangs. I'm not overdoing it. 0.1. No, let me just make it 1. And I'll just color it for okay. Looks a lot better. And you can kind of see it fade out from the overhangs. Although I do think yeah, that overhang thing should have been there. Okay, now I figured out what this was used for. This is bringing the overhangs, which for some reason okay, they were at 150, but they should actually be 45. And there should be 0. Nope, that's not right. Nope, that's not doing anything. Yeah, you could use a sculpt and displacement texture. This is strange, but I will make it to 150. That's weird. 0.5. Okay, I think we just have to keep playing around with this number. Make this 65. Okay, that looks good. Overhang, yes, that's the reason. We need to make sure that when it prints, we don't have too much overhang here. And we're gonna go through one more step to make sure that happens properly. Okay. So this part, we will take it into Blender. I'm not sure what that null is there for. But anyway, you want to save this as an OBJ. Overhang detect. Now this save is going to take a while because it's a huge file. And this is the point where you might want to think, hey, do I want to do the same thing, but use less subdivision steps? So you can go back a few steps back to the earlier file and subdivide it less, and then do this. Do it with fewer subdivision steps. Okay, I'm just going to make a new Blender file. A, X, delete, side view, import, obj. Oh, is it done writing the file? I think it is. Okay, perfect. Now you go here, N, and then 3D print toolkit. So if you don't have that, go to preferences, add-ons, then search 3D print, and you'll find it like 3D print toolkit. Okay. Click on overhang. Then tab. And we'll get a selection of all the overhang faces. And boy, there are many. Not that many on the outsole. Interesting. Okay. Shift D. Sorry. P to separate. And you want to make the original mesh invisible. Into edit mode, and then delete this, not needed. Select this stuff, this stuff. Cool. So the stuff that you want to select is either the inside of the last, like this area, or the region marked out on the ZLFL Discord, which goes, where is it gone? Yeah. See here, this stuff is the stuff that you want to select, plus the inside of the last. So there's a bit in the inside of the last, inside of the shoe, which is at the top, which you can select. And then you want to go select linked, and then linked. And it'll just select everything that's joined up. You press X, delete vertices. And there you are. Now these are all the actual overhangs that we have to worry about. Cool. File, export, OBJ. And let's call this overhang areas. And limit to selection, and you don't apply modifiers. Cool. Now we go back here and get that file in. Now we can see where the actual overhangs are. We get the distance. Dist overhang. Okay. Dist overhang. Maximum. So same thing, getting the minimum and the maximum. Well, so same thing as last time, except with that maximum. Dist overhang minimum and dist overhang maximum. I have no idea why it suddenly decided to solve stable diffusion. Is there a way to create an optioneering interface to make multiple alternate versions of the final shoe before exporting an OPJ? That is interesting, and I haven't tried it. I guess there would be a way to do that. You either want to investigate task operators or doing it within the SOP interface. But I think that stable, the MLOps is really, it does not work well when you have multiple things going on, multiple MLOps things going on at the same time. So that might not be the best. That might not work out, like it might crash. But I would guess that if you didn't want it to crash, you could use task operators. That would be the way that it would conceivably not crash. Can you create perforations through the mesh? Yes. That's not what I'm going to focus on, but that is possible. Like you could model those holes, or you could use this, use the textures to create holes. But that's not what I'm going to focus on, because if you, I mean, you could print it on your own, but for you to make holes with Celapel's shoes, it's very difficult for them to check that the shoe is reliably printable if you make holes. So it might not be the best idea to do that. Okay, so we can kind of see the distance from the overhangs here. Why they are not moving is beyond me. Usually when these don't move, you want to blur them out a little bit. So I'll just put in an attribute blur, delete this, and get the dist overhang. Why is that happening? Dist. Oh, so silly. Nope. Something like that. Um, um, well, yes, but they're like, it's difficult to know if you have the right threshold, I guess. So I just went to Blender just to make sure. But if you can find a way to know the right threshold, please let me know because I wasn't able to figure that out yet. I think there is probably some way to find out the exact right threshold, but I couldn't find that. So I was like, let me just go to Blender just to be sure. And yeah. I'm not sure what it is super weird. Um, that's not changing anything. I'm not exactly sure what I'm doing wrong. If anyone else can spot it, please let me know because this one is different from this one. Let me just try to copy all of this over there. The displacement is going outwards from the mesh. I use Blender to render. I don't know how to use Karma just yet. Oh, that's weird. So I couldn't figure out what exactly was happening. So I just copied it over. Let's see if this works. Yeah, that's so strange. Okay. Anyway, maybe it was the way this was. Nope. Same thing. Just a different attribute name. Okay, whatever. So then these regions, unfortunately, will have to get like blurred out and stuff. And put the update on auto. I think what could be cool for the future is if we could like segment out different regions based on like the distance between these mesh islands, and then say, okay, here we're gonna have like less we're gonna have less of this blend, and other places we'll have like a tighter yeah, here we'll have less, and then there we might have more. But anyway, I'll just continue. Then what we do is a blend shapes. Between the original, which was here, and this one. And set from attribute. Just overhang regions. Yep. Looks like the blend has really taken place. Yeah, here you can see it is quite apparent. Now the problem is that once we do this, that's just going to create more overhangs. So the only way to completely remove all of the overhangs is to finish the decimation and then manually go into like Blender sculpt mode and remove overhangs. So let's do that right now. Wow, that's quite cool actually. Yeah, overhangs are places where it won't be able to print. What I think needs to happen is this needs to be a little bit reduced. Okay, cool. That looks better, I guess. Fine. Now time for decimation. So this node will like reduce the polygons as the name says. And we want to reduce this to about 10%. And this will be like quite memory intensive. Takes a while. Okay, that's what we've ended up with. And for some reason, did I color the mesh? Oh, I did. I should not have done that. Yeah, much nicer. Now, when we export this to Blender, there are going to be a whole lot of areas in the mesh which have like tiny overhangs, which will have to be dealt with like manually. And let's do that right now. Um, import obj. Does it have colors? No, it doesn't. So I've rotated it by 120. Let's check the overhangs. That is way fewer than I thought there would be. I am like reasonably sure we could get rid of them without going into sculpt mode. But just for the sake of like explaining how to do this, I'm gonna Shift D to separate, then click on this. We go into sculpt mode and like frantically search around for the shoe. Here we are. And then what you would do would be turn on time topo, okay, and go to the smooth brush, and then just start smoothing stuff out. So this is one way of doing it. But the like more accurate way would be to just use the edit mode tools. I will do this way because it's faster, but I can also show you how to use the edit mode tools to do it. So let me just go back to layout, hit tab. Oh, let me check the overhangs. Not that many. Yeah, here. Okay, so if you want to use the edit mode tools to do this, you would go here, turn on mesh analysis, and then just like slide these down. There's got to be like one or two more overhangs here. Okay, not bad at all. I think that we can ignore this. Actually, you know what? Let me fix it. Thank you, Giorgio. I guess if I have time, I can go through that file. Thank you so much. That was actually really nice of you to make that really fast. I can tell that you're probably way more experienced. And by the file name, it says TA, so technical artist. Okay. Yeah, everyone, please thank Giorgio for that because I was not able to figure that out. Thank you so much. Okay, I cannot spot any more overhangs, so I'm just going to say this is good. And R120, so it's back down. And yeah, now I'm going to show you guys how to export this from Houdini. You can export it from Rhino, but I think it's nicer if you export it from Houdini. Export. OPJ. going to select only, don't apply modifiers. Cool. Okay, so here's the file with the overhangs removed. And there's also, before the decimation, here is where we want to use the same threshold attribute triangle. So first what needs to happen is grading. Oh, Self-Help manages the sizing on their own. Plus, when you order a shoe from the website, you get like an option to use custom sizes. But I will say that they have messed up sizes beforehand. So they need to work on that, I think. And I think they have worked on that, like they fixed most of those issues already. Okay, just gonna snag this attribute triangle from here. Oh no. Oh, yeah, this sometimes when you interrupt it, it just gets stuck like this. Group walls. Okay, I'm just gonna save this. How to add thickness for 3D printing? I don't exactly know what you mean. Okay, I'm just going to restart this file because I think I glitched it. Okay, it seems like we won't get enough time to do all of the rendering stuff, but that's fine. I have included a file and I'll explain a little bit about that. But let's see, maybe we might. Okay, time to let the file run. So the way that the rendering works while this file is running, I'm going to explain, is you take the closed wall region, which I'll explain right now. And you put that in the file that I put on the Google Drive very recently. It's called Zellerfeld walls cutting. And what you get is essentially two different regions that you can slice in Cura and then export the G code. open the G code in Prusa Slicer. And then from Prusa Slicer, you can get a renderable image. Oh God. Oh no. How did this happen? That's how it happened. Okay. Back to the important part. Right here, attribute triangle. What's up with it? Okay, so what I've done is I've used the color to select where the walls would be. And this is something that Sellafield is still updating their guidelines. Yeah, the white parts are raised. So Sellafield is still updating their guidelines, but essentially what we would do is, at least for now, for the purposes of slicing for printing or slicing for rendering, you could use this. But when Sellafield asks you to provide closed wall regions, you would want to provide more accurate closed wall regions which fit this mesh instead. So that would be like this instead. But anyway, I think we can use these as well. Let me just read that. Really, so. Okay, perfect. Now we have this. Now we can do all of the transformations and all of the exporting that we need to do. So first things first, let's submit to Sellafield. So oh, that's not it. And you have to rotate this 90 degrees. And the reason being that when Houdini exports a BSDL or a binary SDL, I think all SDLs, they kind of get rotated on their side for some reason. So you have to counter rotate it essentially for it to get imported in the right position. And also the normals get reversed. So that's the right shoe done, right closed walls, and this is the last. So I'm just going to use the same last because why not? Oh, I'll find the last. Subdivide the last 3 times. 3 times is enough, right? Let's make it 4. Oh, okay, here we have the left last. Oh, left shoe, left closed walls. Let me just put this. Okay, cool. That's the left last, left closed walls, left shoe, then right closed walls, right shoe, and right last. So the first thing you want to save is the last. Let me just save geometry. Oh, actually, I'll just make a new file, new folder. Result. File, save geometry, then choose wherever you made that folder, documents. Synthetic odd. Last. Right. And accept, and then make that BGO into BSDL. Save geometry. To right. Accept. Okay. Shoe left. Okay, perfect. Now what we can do is just go into, yeah, here. You have to rename all of these. So you have to remove the B in BSDL and just make it SDL. It's kind of stupid that Houdini makes you do this because you can't even import them back into Houdini with the BSDL format, but you can when you just change the name to SDL. Anyway, they aren't very heavy files. Perfect. Now we go to the ZFL Discord and go to submit model, submit. You put your brand name, Y, synthetic kicks 1.0. Is that right? Perfect. Okay. Ticket upload. Last type, traditional, last. Shoe left. So shoe left. Then last. Oh, that's weird. My bad. Shoe right. Shoe right. Shoe left. Last right. Last left. And enter. Okay, now we'll see. Oh, sole height right failed. That's weird. Let's check that in Blender. This is pretty much the same thing as the Y. Okay. Five. That makes zero sense whatsoever. Because that is a 35 height cube, but the sole height is not passed. Okay, I don't know how to fix that, but I don't think it's a scale or unit issue. but I think it's fine. I think this is the kind of time that you would want to email Luis. So Luis's email is in the Luis's email is in here. So I would actually go and email Luis about this. That's exactly what I'm going to do tomorrow morning. But yeah, usually it should work. This is something that they just, so this bot is something that they just implemented like, I think a week and a half back or 2 weeks back. So that's why also the Discord link I will just send once again. That's why they're still like testing it out and stuff. But I will email Luis about this because it doesn't look like there's some issue. This is a cube. There's no scaling issue because we have already we use the same scale throughout and we haven't like scaled the last or anything. But at least it passed the overhang check. That's good. Or did it? It says okay, let me try again. Shoe right. Shoe left. Last right. Last left. Okay, while this happens, I'm gonna run a completely different file. Let's just get I just sent it. Oh, my bad. I sent it to the hosts and panelists. There we are. You're most welcome. Okay, so I'm gonna grab these closed walls, save geometry, save this as closed walls, right? Closed walls, right? And let me just open. Okay, I still said sole height. That is very strange. Oh, maybe it's too little. I consider that. 1 second. Cube 12. Nope. Nope, that is also not the case. That is really strange. Okay. I think the bot has just glitched a little bit. Okay, so this file has like it does these. Oops. Ooh, right. Last, right. Okay. So I'm just going to quickly go through this because we don't have enough time. But what this does is this file slices the shoe into two separate meshes. But we don't even need that actually. Okay. Okay, so this is what we've taken the outside the closed walls region and we projected it onto a last, but the last is like a little bit shrunken, I guess. And then what we do is remesh it like volume voxel remesh it. Okay, I hope we can get to the rendering bit. Okay, not bad at all. I'm gonna up the adaptivity a bit. Save, jump. Oh, okay. One sec. Did this not work? Let me just try this again. Okay, cool. So I've already put this file up, and what you want to do is save this one. You don't want to actually go through the whole file. Save geometry. Oh crap. Design webinar. Closed walls. Volume. This is taking an awful lot of time to save. Okay, so what you want to do is import your files. Uh-oh. That is so weird. Why is it taking so long? Okay. Okay, let's hope this saves quick. Okay, that kind of worked. Save geometry. Okay, it's saved, thank God. Yes. Import file. So when you make these supports, you want to model the supports using the collar region. And that's something you can do procedurally. I'm not going to show it because I'm more interested in the rendering bit. I guess I mean, hopefully if we can import this and within the next half hour, if I can try to render it. All right. No, okay. Okay, I had to rotate it because I forgot to do that. Whole thing. Gotta flip the normals also. Yeah, okay, that looks better now. So the way you want to make the supports is by getting this region, which you could probably get from one of these parts in the Rhino file, and then just blocking out this region. And you don't have to worry about the interior. It's only the collar and this part. I'm not really going to go into that, but I guess you would get the idea. This part and here would want to go, you'd want that to go and touch the base of the 3D printer. All right, let me just export these as a 3MF. Export selected. So you want to export this as a 3MF because when you import them into Cura, and if you import them as two separate STL files, they won't be lined up. But if you export it as a 3MF, Cura will detect them as two different meshes, but they'll be lined up nicely. Let's open Cura. Now, this is something that you could install later and try out later. Okay, cool. So you want to have 0.4 nozzle, 0.2 layer height, 45, let's make it 40, zigzag, and no walls. So make sure that you have no walls, 0 wall line count. Yeah. No, this part is not necessary, but it's cool. And maybe we can get a render out in the next 25 minutes. Let's see. Okay, I've moved it into location. You want to also turn off in Cura, you want to turn off the snap to base. Okay, here I click on this, click on per model settings, modify settings for overlaps, wall line count 1. Infill pattern. What is it? Cubic. And I keep the infill density as like maybe 10. This is just for the render, but in like real life, if you're going to print this, your print settings would be very different. Like this, it would first of all depend on what filament you're using. If you're using an 80 to 85A Show value. That's a look. The perforated texture is something that ZLFL does with their manufacturing process. But yeah, 85A should give you around maybe 30 to 60 zigzag infill, and this should be something like 25 to 40 cubic infill. Okay, anyway, let's slice. Let's see how it looks. And let's hope Cura doesn't crash. Oh boy, it's taking a while. No, it's not. It's just to make a cool picture. Oh, oh no. It failed to slice. Highlighted areas. Oh God. Okay, I'm gonna show you guys an example with a different file. Let me just open a completely different file. Cool. Yeah, this was like one of the earlier prototypes that I did. So I'm just gonna do the same thing. But this one, I didn't use the infill method. It's just a surface wall. So overlaps, wall line count, 2. And yeah, let's just slice. So ideally, if that would have worked, we could have gotten something out of it. And the slicing would have looked different than this because this is just a surface that was like volumes that we had created. Let's hope the slices out. This is also taking a long time, which is concerning. Okay, I'm just loading up a different shoe, which is not AI generated. But let me see if it works out. Okay. So this is what I meant by like, this is how you would create the closed and open wall, open shell region. And sorry, this is how you would create the closed and open region regularly. And this is how you would make the supports. You would have like one support projected from the collar and one from this back part. Then when you preview it, so we've used cubic infill over here and zigzag in the upper and made like a region with low density. And it has walls. So this region has walls. So similarly, that region would have had walls. I'm going to cancel this. Anyway, let me just open up a render file. I think that's the best way to do this. How much time we got? Okay, about like 20 more minutes. Okay, so just pretending we've actually done the slicing, because it wasn't I've already sliced this, so I have the sliced file. And you can see it looks like this and whatnot. But what you would do is you would open the G code like I have with Prusa Slicer, and you would go File, Export Toolpaths as OPJ. And then that would take a while to export because it's like a 2 to 6 GB file. Let me just get to my renders. Yeah. Okay. Opening up Blender to show you the render method. Yeah, the tiny overhangs are negligible when printing, but ZLFL's bot is just that strict. And I guess in the future, the bot will get more and more like accurate and less stringent. But this is my shoe that I released with ZLFL, and this is like the textured closed walled version. And this is what it looks like once you import the G code. What you have to do is actually go through the materials, delete each material, because it comes with like 5 different materials. You have to just delete all of them, and that takes a while. And when you import it, there's also this line, which is like a purge line, where you have to actually enter edit mode with this enormous file. Enter edit mode, delete that purge line, go into like X-ray mode, toggle X-ray, delete the purge line, and then exit edit mode. And then you can bring it into position. And then what you do is light it up nicely and get some sick renders out of it. And there is a way to do this much faster using, I think, Blender's curve hair rendering technique, but I haven't figured that out yet. I've seen someone on LinkedIn and Instagram do it. I think their name was Albin Merle. They did something with 3D printed G code rendering, which was much faster than this and would probably be much less GPU intensive. But you can see how it looks with the G code exported. You can see like the perforated texture. Someone was asking about this actually, like how does the perforated texture work? Well, this is how it works. It's because of the way that it's sliced. And generally, some tips I would say, some tips that you could use when designing for 3D printing for ZLFL specifically, is to make sure that you take advantage of the texture, but also make sure that you get like you get the outsole a bit more closed. So you can see that over here the outsole is still closed, and then the open area starts above. I would say that Zellerfeld shoes tend to absorb quite a bit of water. So you want to make sure that you're keeping your shoes a little bit more watertight once you have this. Well, right now they haven't released the closed wall update, so you don't have that water problem, but we wouldn't have that water problem with these. But with this texture, you do have water seeping in and getting absorbed. But with this stuff, you won't have that. So if you're designing for like a rainy climate, you want to keep that in mind. And what else I would say? I think that focus on making really contrasting shapes, because it is a monomaterial shoe. It's going to be thank you. It's going to be like not very visible from afar, so you don't really see how intricate your design is if it's super subtle. But if you make a design which is really really chunky, let me go to the SideFX website and show you. Like this is a great design because it's got a crazy amount of contrast, and like this shoe would not work with the current system of submission. Actually, this design also, it sells really well. This is by Kyle. He's a really talented designer, but it sells really well because it's got crazy contrast and it works really well on the website. This one also, this is by Svet, who works at Zellerfeld, so he knows his stuff really well. And he's really taken advantage of all the contrast well over here. So if you guys are like designing shoes for Zellerfeld and you want to keep in mind the fact that it's going to be a monomaterial, and keep in mind the fact that that you need to have more contrast. Q&A. Yes, they will really print it, but you will have to wait a while because there's like a huge line of brands and collabs and whatnot. But you will, if you submit it and if it passes their checks, or if you talk to Luis and their bot is wrong, then yes, they will probably print your shoe and sell it. Could we do all of this in Blender? Yes, of course. I mean, you could do everything in Blender and not worry about AI texturing, but I guess the point of this webinar was to learn how to texture stuff with AI. But yeah, oh yeah, another thing is you can like add cool faces and stuff. I think that's really cool. Yeah, I guess that's it. I don't have anything else to say.
Perfect. Thank you so much, Kedar. If there are any questions, guys, like towards Kedar, now is the time.
Sure. I'm sorry for taking all your time. I know I went about an hour over.
Oh, that's great though. Like it was just more learning for everyone, you know, so that's amazing. Thank you.
Okay. Got any questions?
Guys, do we have any questions?
Do you get commissions? Yes, let me explain the business side of things. So this is actually really important, and I should have explained it earlier. So every time when you upload your shoe, they give you a contract telling you how much your shoe costs to print on average based on all of the sizes, just put on average, and how much and then you decide how much you sell it for. The minimum can be $250. So you can see everything is mostly $250, except for like the more wacky ones which have more money. And once you decide on your price and once you decide on your price, you figure out your profit. And after selling the first 50 pairs of your shoe, then you get 60% of the profit. So that's how it works. And is it possible to print a high top boot? Yeah, you can do that. You can do that with ZFL, and you can print it at home as well. And I would recommend if you're buying a printer, there's like 3 levels. I have it in my notes. One second. Let me just find it. Uh, so there's the artillery sidewinder X2, X3 or higher, which is like a good cheap printer. Cheap as in like that's how that's like the cheapest decent printers get. ProForge 4 tool changer is like pretty good. It's up there. It's like up there with Prusa. Then there's Prusa XL, which is like basically the best. Then there's Soval SV04, which is like a cheaper version of a Prusa. You'll get the dual material capabilities, but um, you won't get the reliability, and you'll have to keep calibrating it, and it's a real pain to use. And the Soval SV07 Plus, which is just a really big printer with one print head, I think. Okay. Are there any other platforms? Yes, there are. There's Cubes, which is pretty good, and I think Fabrizio is here in the webinar. I'm not sure, but he's working with Cubes, and they give you way more freedom than ZFL does. So you could probably do more interesting things with Cubes, and ZFL will have more restrictions. And there's also like if you want to get into manufacturers, then there's like a lot more. This, but you would have to design for like resin printing. So there's polypolymer, which is what Scry and Comp Conception, Aliform use, and like Costica Spa is also used polypolymer. And then there's HP, who you probably have to negotiate quite a bit with because they have huge clients. And then, I don't know, Lux Creo, Carbon, Oshler Carbon, which used to be exclusive with Adidas, but now they aren't exclusive with Adidas anymore. So you could probably talk to them. But all of these people would have like minimum order quantities and stuff. I didn't really understand the mesh texture. So that's the zigzag and fill. So if you have zigzag and fill, it'll look like that mesh texture. And yeah, that's what it is. Basically, it's just the 3D printer infill with no walls. Oh, I'm missing out a whole bunch of questions. Oh, Bamboo X1. Yeah, Bamboo X1 is really good. I think I don't know how. I haven't seen someone print a wearable shoe on them yet, but I think they're really cool. Thank you. I think I'll have to be more prepared for a part 2. I was like a little bit scared. I mean, I was a little bit nervous. Um, any printing platform master list? No, I don't think there is one. But I think maybe in the future, Fabrizio might look something up. But I think the main thing is to try doing this yourself, like at home, printing, and um, like look into what kind of filament you want to use. The harder the filament you use, the more light you can make the shoe, but it's less comfortable. Thank you, Luke. Thank you, everyone. Flexible resins, EPA 45 by Carbon. I don't really know, but I've worked on a project for polypolymer, and I know the resin is really good, and it's very similar to Carbon's EPA 45. I think that's the name. Let me just Google it. EPA 45. Nope, that's not it. Okay, I know that I would say that Carbon would be the best. Any tips on how to have more than 50 sales? Marketing, marketing, marketing. Just position your. I think that honestly, the design of your shoe is kind of secondary. I know it sounds sad to say that, but just marketing makes your thing way better. I mean, it makes your sales way better because you just reach more people. I have like I think 82 or 85 sales or something now, but that's like after a long time. And I know people who have marketed this stuff really well and get a lot of sales. I would also say maybe don't make a mule. Yeah, it's just meme marketing. Meme marketing is really important. And I think that I think that really successful designs these days, like commercially successful designs, are all like have some sort of memeable aspect to them that makes them viral. Mischief does that really well. Well, I mean, I have a course with the Protology Lab, but that's pretty much the same thing as what I showed you here, minus the Houdini, but with a bit more Blender. And if you want to get into like, there's also Tom Humphrey's YouTube channel. Let me link that actually. Tom is a good friend of mine. Yeah, he's great. He has like a lot of tutorials and like live gravity sketch stuff. Tom has worked with a lot of pretty big name designers. What is a good percent study? I don't percent study to look at. I don't understand what that means. Q&A. Who's at the current 3D footwear designers? I really like Comp Conception's work and Scry's work. Like I've followed them for a long time. Amazing. I'll link their stuff. I think resin is good. I would say the only downside is that it's not as like not as recyclable. It's not biodegradable. There is a company which does make biodegradable filament, Balina. Let me link their stuff. They are awesome. Actually, I'm so glad that they're doing it because nobody else has managed to really. Well, I guess people are managing to do it now, but I guess they were the first ones. I think that flexible resin is good though. Like When it's done well, it's good. I actually don't like the Adidas 40 forward shoes. I have a pair, and I think that they're like a little bit too hard and they don't push you forward enough. And then now they don't even use that anymore. Like they have a molded version, which is suspiciously similar to a on running shoe. And that one actually gives you more forward motion than the 3D printed one. So I guess it depends on how you use it. And there's a lot more space to do things which are interesting with resin than with FDM because there's less restriction. Then again, it's more expensive. Yeah, you do lose properties. Like every time you recycle TPU, it becomes like if you have like a 70A, then after that it become like a 84 or 85, and then the third time will come a 90, and then after that it's going to be just hard plastic pretty much. So I don't know. Luis, who is going to give a talk at Computational Design next, might know. He did a master's degree in TPU recycling, so he would know probably.
Perfect.
Okay. Thank you, everyone. I'm so glad I got to do this. Feels like I've come full circle.
Yeah, thank you so much, Kedar. It was really a pleasure, really interesting workflow, a lot of new knowledge. Thank you so much for answering all the questions. It's really like being a pleasure. And
Thank
we
you,
wish you
Pavlina,
all the
for
success with all your new endeavors. Super exciting. And thank you everyone for joining us today. You'll have like in a couple of days like your recording, so you can go through like over everything that like you watched today. All the best, everyone. Take care.
thank
Bye
you. Bye. Thank you so much, everyone. Thank you, Pavlina, for having me here.
bye.